All right, I wanted to go over some problems from the notes on Thursday. Just wanted to do a blank version and go through a problem for you, and hopefully it'll clarify maybe some questions you might have. If you want me to go over some other problems, please shoot me an email. I forget which number this is. This might be 12.1, I think. For this problem, you're asked to find the distance between, I think, B and P. So the first thing I'm going to do, according to the steps in the notes, is from the smaller circle, right? From the center of the smaller circle, you're going to draw a line parallel to the tangent line. So in this case, X and Y, right? Point X and point Y are the tangent lines, okay? So I'm going to draw a line from here to here that runs parallel to this segment XY. So here, I drew in this line, okay? And so then I'm also going to actually draw in what I'm trying to look for, right, is this right here. Okay, hopefully this will stay right there. Okay. All right, so then what we're going to do, okay, so then we learned that from the radius to the tangent, that's always 90 degrees, okay? And so if this is parallel, right, then what we're actually creating here is a rectangle, all right? So if this is 15, then this must be 15, right? This is 15. If this radius is 3, right, if this segment is 3, then this is 3 right here, which means, and if this whole radius is 7, then the leftover right here, that's 4. Okay. And if this is a right angle, this is a right angle, and so here is the right triangle that I was talking about in the notes right here. Okay. So this segment OP is actually the hypotenuse of this right triangle. Okay. All right. We'll label this here X, right? So then what we have is 4 squared plus 15 squared is equal to X squared. And then we work that out. Okay, in this problem, find the length of the common internal tangent. Okay, well, what is that? All right, we'll get to that in a second. All right, so two circles have radii of 10 and 5. All right, that's going to be important. Okay, so first what I'm going to do is I'm going to draw, right? Oops, that's terrible. Okay, so I'm going to hope that I drew this slant kind of at a good angle here. All right, so what I'm going to do is, right, I'm going to have these points here, okay, and then I'm going to draw in this radius here. I'm going to draw in this radius, okay. I'm going to label those, right, we know this is going to be 10, and that's 5, okay. And then also between those 2 points, right, I'm going to connect a tangent line. Okay. And then just like the from the notes, all right, that first step was from the smaller circle, from the center of the smaller circle, you're going to draw a segment, right, that's parallel to the tangent. So something like this, right, it's parallel to this. This new one that I just drew in, this is the internal tangent line, right? This one would be the external because it's on the outside. But we know that these are going to be the same measure, okay? We also know that, well, if this is 5, then this is 5, and so this leftover is 5, right? Okay? Their centers are 18 units apart, so this whole thing is 18. Okay? And here's our right triangle. Okay? If this is a right angle, this is what we're looking for right here. Right? That's our X. Okay? Right, so we have x squared plus 5 squared is equal to 18 squared. All right, so there it is. Okay, hopefully that helps. For this problem, I think we're in 12.2 now. I think I said I wanted to go over this problem. How do we go about figuring out what x is, right? Well, if x represents the radius, okay, we can actually draw in from the center either to this part of the chord or this part of the chord. It doesn't really matter which one. Okay, I'm going to go draw it this way here. All right, and so I'm going to rewrite that. So this is x. Okay, and we also learned that part of the radius, right? If it's perpendicular to a chord, it actually bisects it. So this is actually right here. I'm going to make this red. This is actually 5 right here. Okay. So then we have this right triangle. So the radius x ends up being the hypotenuse. So we have 4.2 squared plus 5 squared is equal to x squared, and you can solve it from there. All right. This one, I wanted to go over this one because it looks a little complicated, but I thought it'd be a good problem to go over. All right. Circle A and B are congruent, meaning they're the same size, they overlap. Okay. CD is a chord of both angles, right? And so if you can try to imagine, right, if you take away this left circle, right, CD is in circle B. And if you take away the right circle, CD is also in circle A. Okay. AB is 24. Radius is 13 for each of those. How long is CD, right? What do we do here? So the first thing I'm going to do is note that AB is 24, right? And so what this actually does is from here to here, right? That's 12 and 12. Okay. Now, when you have a circle, you can always draw in a radius, right? Anywhere, right? You can do this, right? You could even draw it from B if you want, right? You could do this. Doesn't really matter. Okay. I'm going to stick with this one. This is the first thing I did. Okay. There's a radius of 13, right? So that means this radius is 13. Okay. This is going to create a right angle here, okay, from the radius to the chord, right? It's perpendicular. And so we have this, right? This is our x value. Okay. If we can figure out x, then we multiply by 2 to get all of CD, right? You could do x squared plus 12 squared is equal to 13 squared. Or if you recognize if 13 is the hypotenuse and one leg is 12, this is actually a triple. This is a 5, 12, 13 triangle, right triangle. Okay, so x is 5, so therefore CD is 10 units long. All right, so hopefully you followed along with that one. Okay, so those are the ones that I wanted to go over. Hopefully it helped. If you have questions, please shoot me an email, and then we'll take the quiz on Monday, I believe.